x. X is either equal to 2 plus 5.66 over 2 plus, or 2 minus 5.66 over 2. So x is equal to 3.8, or x is equal to minus 1.83. Okay, so you just really need to remember, because the only place you're going to fall over, if b is negative, then you know, we've earned x equals minus b plus or minus, and let's say b is minus 3, that's minus 3, that turns into plus 3. Okay, and know how to tease out your a, your b, and c. Best thing to do is to write out your equation and write out this ax squared plus bxc form underneath and just block them off like that. That's the best way to do it. A equals 3, b equals minus 3, c equals 7. Now let's look at solving simultaneous equations, but in this case one is linear and the other is quadratic. It has like something squared in it, okay? So here is the an equation x plus y equals 3, and another equation x squared plus y squared equals 17. This is actually the equation of a circle here, and this is the equation of a line. So actually the solution of these, the x and y values, would be the points at which the line cuts the circle x and y. At some point there, x and y, at some point here, x and y. Okay, and if there's only one solution, it's a tangent. Okay, but anyway, don't worry about all of that. Just how do we solve this? Well, always the way to solve these is to first express x in terms of y in the linear equation. So if x plus y equals 3, x is equal to 3 minus y. Okay, then we sub that x equals 3 minus y into this equation, the circle equation, the second equation. So where we see x, we put 3 minus y in brackets, squared, plus y squared is 17. So that has to be multiplied by that, because that is 3 minus y squared. That should lead to this value here, which when we gather the like terms and do our bits and pieces, we'll end up with 2y squared minus 6y minus 8 equals 0. That's the quadratic expression we need to factorize. The factors of that are 2y plus 2 and y minus 4. You can try that yourself if you want on the sheet, but it is. And then we let, bear with me, we let 2y plus 2 equal to 0, because it's what we do with these factors when we're solving, trying to find a value for x or for y. So we get y equals minus 1. And we let y minus 4 equals 0, and get y equals 4. Now we need to find the corresponding x values for these y's. So if we put y equals minus 1 back into x plus y equals 3, we get x is equal to 4. So we actually have our first point here, 4 comma minus 1. And then if we sub y equals 4 into that first equation here, then we get x equals minus 1. So we have another point here, x is minus 1, y equals 4, and they're the solutions. And as I said, they are the 2 points where the line cuts the circle. Okay, so let's learn now how to find an equation given its roots. So just the best way to do this is just by example, really. Form the equation with the roots minus 4 and 5. So x is equal to minus 4, or x is equal to 5. So if that's the case, x plus 4 must be equal to 0, and x minus 5 must be equal to 0. So x plus 4 and x minus 5 are the factors. If you multiply those two together, you'll get the product that is the quadratic equation, and the equation with those roots is x squared minus x minus 20 equals 0. Second example, form the equation with minus a quarter and 3. So if x equals minus a quarter, we can cross multiply here. We can say 4x equals minus 1. So we can then say 4x plus 1 is equal to 0. That's one factor. X is equal to 3, so x minus 3 must be equal to 0. That's the other factor. If we multiply those two together, we'll get 4x squared minus 11x minus 3. Okay. Now, I know some of you might be a bit thrown by the fact that we cross-multiplied here. You don't have to do that. You could do as we did in the first example. You could say x equals minus a quarter. Therefore, x plus a quarter equals 0, and that is a factor. And x equals 3, so x minus 3 is the same factor as we had there. Okay, and it would still work out. If you multiplied these two together, you would get the correct equation, quadratic equation. Okay, as down here. So either way works. Both ways are fine. To do it the cross multiply way, or to do it this way with the fraction. And to not end up with a fraction in the equation, you'd end up multiplying everything by 4, and you would end up with this. Okay, let's look at the laws of indices. Okay, so the first law is multiplication. Now, bear in mind now we've the same base letter or base number that we're multiplying, and we say a base number because it's the base, and high up from the base is the indice or power or index. So if I have a cubed times a squared, I add the cubed and the squared, the 3 and the 2, that's a to the power of 3 plus 2, it's a to the power of 5. I add when I'm multiplying, I add the indices. If I have 6 cubed times 6 to the 4, that's the same as 6 to the 3 plus 4, it's 6 to the 7, I add the indices. Okay. If I have 6 squared plus 4 squared, I can't add the indices because the base numbers are different. So that's as you see it. If I'm dividing, if I have a to the 4 divided by a to the 2, I subtract. I have a to the 4 minus 2 is a squared. 6 to the 6 divided by 6 to the 3 is 6 to the 6 minus 3 is 6 cubed. Okay. The third rule states that any number to the power of 0 is equal to 1. So 10 to the 0 equals 1. 100,105 to the 0 is equal to 1. 20 to the 0 is 1. X to the 0 is equal to 1. Anything to the power of 0 is equal to 1. You can try that on your calculator. Okay. What about when we have a power raised to a power? So what if I have x squared inside the brackets all to be squared? I actually multiply the inner power by the outer power. So x to the 2 by 2 is x to the 4. X cubed in the brackets all to the power of 4 raised to that power of 4 is x to the 3 fours is 12. 4 inside the brackets all to the power of 5 is 4 to the power of 2 times 5, 4 to the 10. Now, what about a product raised to a power? So here's a product. A product is like the end answers. If the product is 25, this A could be 5 and the B could be 5. This A could be 25 and the B could be 1. It's the product, okay? But a product raised to a power, A times B to the n is the same as A to the n times B to the n. Okay, so if I have 5c all squared, that's my n there, the 2, that's the same as 5 squared by c squared. 5 squared is 25, c squared is c squared. If I have 6d squared all cubed, that's the same as 6 cubed by d by 2 to the power of 2 times 3. So it's 6 cubed by d to the 6, and 6 cubed is 216 times d to the 6. Then sometimes I may have numbers or letters with negative powers to the minus 2 or whatever. So if I have a to the minus n, my solution to that is, the answer is, it's the same as 1 over a to the n. So I have a to the minus 2 is the same as 1 over a squared. X to the minus 7 is the same as 1 over x to the positive 7. 4 to the minus 3 is the same as 1 over 4 to the positive 3. If I have x to the power of 1 over n, it's a fractional indice, that's the same as the nth root of x. X to a half is the same as the square root of x. 4 to the power of the third is the same as the cubed root of 4. And slightly more advanced fractional indices, if I've not like x to the 1 over 2 or 1 over 3, but x to some other number m over n, then that's the same as the nth root of x as before, but that's all to the power of m. So 100 to the power of 3 over 2 is the same as the nth root, the square root of the number all cubed. That's equal to 1,000.